Yeah, welcome to the lecture on electrical circuit analysis. So, our today lecture is on example problems. So, last class we have discussed the natural response of RL circuit. So, let us solve some example problems on this concept. Okay. So, the learning objectives of this lecture is to solve the example problems on RL DC circuits. Okay. So, this is the example problem. Now, all of you read this question. So, for the circuit below, find the expression of I naught t, I naught of t and V naught of t, V naught of t. When the switch was closed for a long time and at t equal to 0, the switch was opened. Now, see here, see the switch condition now. See, all of you when you give the problem, all of this is switching condition. Now, t equal to 0, switch is see opening direction or closing direction. So, it is opening direction. So, t equal to 0, switch is open. That means, for t less than 0, we have to understand that switch was closed for a long time. Okay. So, this is what the problem. Now, we have to find out the I naught, that is a current flowing through the resistor, and V voltage across the resistor. Okay, load, that we have to find out. Okay. Now, see here, first step is find the tau. Tau means what? Time constant. So, find the time constant tau for t greater than 0. So, we have to find the tau time constant for t greater than 0. We have to redraw the network to draw the equivalent circuit when the switch was opened. Now, see here. So, this is circuit, original circuit. When the switch is opened, so this circuit will be eliminated. This is disconnected. So, only this is the remaining circuit. Okay. So, therefore, this is circuit. So, only here inductor, 2 Henry inductor is there, sorry 2 Henry inductor is there, next 2 ohms resistor, 10 ohm resistor and then 40 ohm resistor. The remaining circuit is disconnected because switch was open. Now, from this how to find out the time constant? What is the tau for RL circuit? Tau is equal to L by R. L by R. L by R means what? R equivalent, RT, equivalent resistance. So, here see here 2 ohm resistor, 10 ohm resistor are connected in series and this combination is parallel with the 40 ohm resistor. Therefore, RT is equal to, okay. So, 2 plus 10, that is because these two are in parallel series, 2 1 for 10, therefore, 2 plus 10. So, this combination is parallel with the 40 ohm resistor. Therefore, in parallel with the parallel symbol, this is the parallel symbol into 40. So, 2 plus 10 is how much? 12. So, 12 is parallel with 40. So, when two resistors R1 and R2 connected in parallel, the equivalent resistance is R1 R2 by R1 plus R2. Therefore, 12 into 40 by 12 plus 40. Okay. 12 4 the 48, 480 by 12 plus 4, 18. So, 18 1 the 18, 18 10 the. So, this 40. So, 10 ohms. 10 ohms is the total resistance. Therefore, what is the tau is equal to? Therefore, tau is equal to what? L by R. L by R. Therefore, L is equal to 2, okay, by 10. 2 by 10 is 0.2 seconds. That means, to decrease the current to 0, so the circuit will take the 0.2 seconds. I told you, so the exponentially the current is decreasing, but how much time it will take, at what rate the current is decreasing means at 0.2 seconds. So, 0.2 seconds it will take to decrease the current from 0, that maximum value, that is I naught initial value to the 0. Okay. So, now step 2. Next step, so we found time constant in the first step. Step 2 is at t equal to 0, time from minus infinity to the 0 minus. At t equal to 0 minus, what I told you, at t equal to 0 minus means minus infinity to infinity 0. So, the switch was closed condition for a long time, I told you already. Okay. So, switch is closing, this is what the switch is closing. Switch is closing here. Now, we have to find out the current flowing through the inductor, that is IL of 0 minus. IL of 0 minus means before switching action, t less than 0. That is the reason I put here 0 minus. What was the current? Now, see, we know that for the DC circuit, okay, when the steady state, the inductor acts as short circuit, because what is the voltage across the inductor formula? VL is equal to L into DIL by dt. Now, if you apply the DC current, so IL is DC means what is a constant. So, what is the constant of derivative? It is 0. Therefore, VL is equal to 0 means what? Voltage is 0. Voltage 0 means short circuit. Therefore, this is what is short circuit. Okay. So, this is what the short circuit. Therefore, whenever once the short circuit takes place means, so whatever the current source is there, see 20 ampere current source, this entire 20 amperes will flow through the short circuit path, because current always offer the low resistance path. So, therefore, this entire 20 ampere current flow through this inductor. So, therefore, IL of 0 minus is equal to how much? 20 amperes. 20 amperes. Now, next step is step 3. See, step 1 we found time constant, and step 2 we found what is the current flowing through the inductor, initial current before switching action. Step 3 is at the instant when the switch is open, that means switching after switching action. So, we have to find out what is the current flowing through the inductor, that is what the response, natural response. So, at t equal to 0 plus switch is open, t equal to 0. So, we are finding the current at t equal to 0 plus immediately after opening the switch. See, the current through the, now see, we know the property of inductor. So, the inductor does not allow the sudden change in the current. That means, what was the initial current is there. Let us say this IL of 0 minus is I naught. This I naught is equal to 20 amperes. So, if you remove the, if you open the switch, so the inductor will continue the current. That means, which is the initial current. Therefore, IL of 0 minus, see here, IL of 0 plus. That means, the moment you open the switch, IL of 0 plus is equal to the IL of 0 minus. That is, what was the initial current was there, same current will flow through the inductor, 20 amperes only. So, which is the initial current. Before switching action, what was the current is there? That is, IL of 0 minus equal to I naught, that we found 20 amperes. So, that is the initial current. Now, same current will maintain by the inductor, because the property of the inductor, it will does not change the sudden change in the currents. Okay. So, this is what the moment switching action. Next to. So, by using the current, now what we have to find? Now, see, you found the current flowing through the inductor. Okay. Now, once you find the current flowing inductor, I want to find, see, in the question he asked that. So, we have to find out the I naught of t and V naught of t. That means this one. Okay. This current and this voltage you have to find. Voltage resistor and current flowing through the resistor. Okay. So, here I am using the current division, see here. Now, this is the current source. See here, inductor behaves as a current source. Okay. So, I use the current is dividing like this in this resistor and in this resistor, 10 ohms and 40 ohm resistors. So, I am using the current division principle to find out the current flowing through the resistor. So, what is the current division principle? The current flowing through the resistor, okay, any element is equal to the parallel, the current division principle is like this, the current flowing through the any parallel connected elements is equal to the total current into opposite resistance by total resistance. Therefore, I want to find out this I naught. So, this current is equal to, total current is how much? Total current, inductor current is 20, because IL of 0 plus is IL of 0 minus 20 amperes into opposite resistance. What is the opposite resistance for 40 ohm resistors? 10 ohm resistance. 10 by, so total resistance is 10 plus 40. Okay, 10 plus 40. So, then you will get the minus 4 amperes. Because see, actually the current, inductor current is flowing in the clockwise, anti-clockwise direction, but we are applying the Kirchhoff current law at this node. Therefore, I am taking the minus IL here. Okay, so minus here. So, you get the minus 4 amperes. So, please observe that. If you are taking the current opposite direction means you have to take the negative sign. Okay, minus 4 amperes. So, therefore, I of t is equal to, okay, so for RL circuit for natural response, what is the current? I of t is equal to I naught into e to the power of minus t by tau. We have derived in the last class. I of t is equal to I naught into e to the power of minus t by tau. Therefore, I of t is equal to minus 4 into e to the power of minus 5t, because tau is equal to how much? What is the tau value we got? 0.2. So, 1 by 0.2 is how much? 5. 1 by 0.2 is 5. Therefore, minus 4 into the power of minus 5t amperes. So, using the Ohm's law, once you get the current, so it is easy to find out the voltage across the resistor by using the Ohm's law. So, V naught of t is equal to what? I into R. So, I is a 4 into R is a 40. Therefore, 160, see this is what the 40 ohms. So, 4 into 40 is minus 160 volt. Therefore, at what rate this see this is the actual current, initial current is 4 amperes, but this I of t is what? The current is reducing to 0, approaching to 0 at this rate, e to the power of minus 5t. See voltage also, see minus 160 volts, but this voltage also decreasing to 0, approaching to 0, because there is no, this circuit is independent of the source here, there is no source in the circuit, there is no independent source here in the circuit. Therefore, the current and voltage must become to approaches to 0. So, at what rate means this is the rate. So, minus 160 into the power of minus 5 into t volt. Okay. So, this is the how to solve the example problems on the RL circuit. Okay. So, thank you for listening to the class. You solve some example problems on the RL circuit. So, apply these techniques. First find out the time constant and find out the current, initial current IL of 0 minus. So, IL of 0 plus is equal to IL of 0 minus, because inductor does not allow the sudden change in the currents. You have to please remember that. Okay. So, we will join in the next class.